Unit 5, Polynomial Factoring. When we talk about factoring, we have to basically break it down to the simplest components. When we're looking at numbers, we're looking at its prime numbers. For example, 20 can be broken down as 2 times 2 times 5. 30 can be broken down as 2 times 3 times 5. And then we look at what they both have in common. Each has a 2 and a 5. So the greatest common factor between those two, multiply those two common factors, 2 times 5 is 10. 10 goes into 20, and 10 also goes into 30 evenly. Same thing as 180 and 420. It's more difficult to try to figure out what is common in both of them by doing multiples. If we break down 180, that's 2 times 2 times 3 times 3 times 5, which in simpler terms is 2 squared times 3 cubed times 5. 420 is 2 times 2 times 3 times 5 times 7, which is 2 squared times 3 times 5 times 7. Both have a 2 squared or a 4 and a 3 and a 5. So multiply 2 times 2 times 3 times 5, that's 60. Greatest common factor for 180 and 420 is 60. I even have more advanced versions, no different though, of 15x to the 5th, negative 12x to the 4th, 27x cubed minus 3x squared. You see it broken down to 15x to the 5th, 3 times 5 times x cubed times x squared. Negative 12x to the 4th, negative 1 times 3 times 2 times 2 times x squared again. 27x cubed, 3 times 3 times 3 times x squared times x. And then negative 3x squared is negative 1 times 3 times x squared. I just broken down their simplest components. And all of them have the following in common. They all have at least a 3 here. They have a negative x squared. And when we do it together, it is a negative 3x squared they all have. I should say a regular x squared, forgive me. So let's look at some problems here. Greatest common factor in 1675. 60 is 2 times 2 times 3 times 5. 75 is 3 times 5 times 5. They each have a 5. We show that right here. And they each have a 3. There's my 5, there's my 3, there's my 5, and there's my 3. 3 times 5 is 15. Greatest common factor of those two is 15. Now I have a factor 5x squared plus 10x cubed. What can I pull out of both those? I'm doing this in reverse. 5x. I can pull out a 5x squared of 5x fifth. That leaves an x squared. And 5x cubed goes into x cubed 2 times. So the final answer is 5x cubed times x squared plus x. Now I'm going to factor y squared times y plus 4 plus 6 times y plus 4. And I can factor out a y plus 4 because there is 1 here and there is 1 here. That goes right there. That leaves a y plus 4. I'm sorry, y squared plus 6. And there's what that is. We'll see more of this later. Factor by grouping. 10x cubed minus 25x squared plus 4x minus 10. And all I really do here is I'm going to see what I can pull out of both of those and get some common groups. Now with grouping, what we're going to do is we're going to try to pull some stuff out. And I'm going to separate these two out. The first two, the 10x cubed minus 25x squared, all I'm going to do is I'm going to separate those two out right here. What can I pull out of those two? I can pull out a 5x squared. 5x squared times can be pulled out. A 5x squared can be pulled out 10x cubed. That leaves a 2x. 5x squared goes into 25x squared 5 times. That leaves minus 5. And then 4x minus 10, I can pull out 2 out of that. Pull out 2 out of a 4x, that leaves a 2x right there. And 2 minus 10 is minus 5. And you see we have a 2x minus 5 with both of these here. Right here and right here. And I can factor that out right there. And that leaves a 5x squared plus 2, which is right here. Now, one of the simplest methods, most effective, is using the PQ method. We have a polynomial, which means there's 3 components, such as, write an example here, x squared plus 7x plus 10. And we want to break it down into 2 simpler binomials, bi meaning 2. with an x plus p, we don't know what the p is, and an x plus q, we don't know what the q is, but we're going to figure it out. And when we do this, we have to know what the p and the q are going to be. And the p and the q have to, when we add up two numbers, they equal 7, which comes from right here. This 7x is 7. And we multiply those two same numbers, it's 10, which is this 10 right here. What two numbers can add up to 7 and multiply times 10? Well, if p is 5 and q is 2, 5 plus 2 is 7, and then 5 times 2 right here, and then 5 times 2 is 10. And now we've factored out our 7x squared, x squared plus 7x plus 10 is actually x plus 5 for our p and x plus 2. Let's look at our example here. X squared plus 5x minus 24. Now I'm going to use the PQ method with x plus p and x plus q. My p times q has got to equal negative 24. And my p plus q has got to equal 5. And again, I got those numbers from right here, 5 and minus 24. So what I do is I create a table. What are all the possible factors that can create negative 24? And the truth is, you don't have to go through every one of them. You have to get to go to the one till you figure out what number the p plus q equals number you're looking for. So I'm looking for negative 24 and 5. So all the factors would be negative 24 is negative 1 times 24, negative 2 times 12 equals negative 24, negative 3 times 8, negative 4 times 6, negative 6 times 4, negative 8 times 3, negative 12 times 2, negative 24 times 1. And then I take those factors and I add them up on the right side here. Negative 1 times 24, or negative 1 plus 24 is 23. Well, that's not equal to 5. Negative 2 plus 12 is 10. Negative 3 plus 8 is 5. There's our number. Negative 3 times 8 is 24, and negative 3 plus 8 is 5. So now we have factored it out. Of all these possible numbers, our final answer is going to be x minus 3 times x plus 8. Let's go through another problem here. A squared plus 7a minus 30. So my p times q has got to equal 30 right here. Excuse me, minus 30. My p plus q has got to equal 7. As you can see, I put all the numbers down here, the factors of 30, negative 1 times 30, negative 2 times 15, all the way across. And then I add up all those factors. Negative 1 times 30, and negative 1 times 30 is negative 30, negative 1 plus 30 is 29. And you can see it's the third one down. Negative 3 times 10 is negative 30, negative 3 plus 10 is 7. And that's the number we're looking for. Now we factored it out. Our a squared plus 7a minus 30, when I factor it out, becomes a minus 3 and a plus 10. Now, up to this point, we've looked at everything where it's just an x squared, not a 2x squared, not a 3x squared, not a 5x squared, just a 1x squared or simply x squared. We can use the AC method. And this, I want you to keep in mind, the letters come from each component of the polynomial. Got x squared plus 6x plus 9, for example. The a is the x squared, the number in front of it. The b is the x, and then the c is the number at the end, the constant. So what we're going to do, and I'm going to easier to show you step by step here, is I'm going to show you how we solve this if the number in front of the x squared, the coefficient, is not 1. Suppose I have the 3x squared minus 10x minus 8. Again, my a x squared plus bx plus c. The a equals 3, the b equals negative 10, the c equals negative 8. So I'm looking at this, and I know I have, very similar to the PQ in the beginning, I got to figure out all my factors for a times c. And that, in this case, is 3 times negative 8, which is negative 24. And like before, I've written all of them down. And like before, I'm also going to create a table and then add those numbers together for those factors. Negative 1 times 24 is negative 24. Negative 1 plus 24 is 23. And I'm looking for the one that matches the 10, negative 10. And it's the fourth one down, which I've circled here. 2 times negative 12 is negative 24. 2 minus 12 is negative 10, and that matches my 10, but we're not done. What we're going to do is we're going to rename this. Where we had our negative 10x squared here, I'm circling on top, there it is here. We're going to make that, instead of negative 10x squared, we're going to rename it as the same thing, 2x minus 12x. 2x minus 12x is negative 10x. And now I'm going to take that equation where I've got negative 3x squared minus 10x minus 8, as I have here. I'm just going to rename it from that negative 10x. Instead of calling 3x squared minus 10x minus 8, I'm going to call it 3x squared plus 2x minus 12x minus 8. It's the same thing. But you're going to see the method to the madness here in a second. It's right here. So I've got 3x squared plus 2x minus 12x minus 8. And now, like we're doing 3 base 4, I'm going to separate these out. 3x squared plus 2x for the first part, and the second part, negative 12x minus 8. Now I'm going to see what I can factor out of these. 3x squared plus 2x, I can pull out an x out of both of those. That leaves me an x plus a 3x plus 2. On the second one, I can pull out that negative 12x minus 8. I can pull out a negative 4. Pull out a negative 4 from a negative 12x, that leaves 3x. And negative 4 from negative 8 is plus 2. And now you see we have a 3x plus 2. We can factor out of both of those. So when I factor out to 3x plus 2 here, I'm left with the x minus 4. My final answer is x minus 4 times 3x plus 2. Very similar to the PQ method, just takes an extra step. Let's do another one here. 3x squared plus 16x plus 5. My a is 3, my b is 16, my c is 5. So I'll multiply my a times c, which is 3 times 5 in this case, and 3 times 5 is 15. And that should be a 5 there, not a 6. Let me write that down. Sorry about that. And then b will equal 16. So 1 times 15 is 15. And really, you don't have to create a table to do all this. If you figure it out in the first or second number, you can stop right there. 1 times 15 is 15, and 1 plus 15 is 16. So I'm going to replace that 16x up here, which I have down here, with 1 plus 15x. And I'm going to rewrite it. Instead of 3x squared plus 16x plus 5, I'm going to write 3x squared plus 1x plus 15x plus 5 right here. Then I'm going to separate them out. 3x squared plus 1x for the first part plus 15x plus 5 for the second part. The 3x squared plus 1x, I could pull out a... let me see here. Boy, I think I messed this up. Let's see. I could 3x squared plus 1x. I could pull out, actually, let me cross this off here. I can pull out an x. That leaves me 3x plus 1. And then the second part, 5x plus 15. That also leaves a 3x plus 1. So even though I originally made a mistake, 3x plus 1 here. So that leaves that here. So it's 3x plus 1. Let me just rewrite it down here. 3x plus 1. And that leaves me an x plus 5. I reversed all this before. Cross off that 3. That leaves me x plus 5. See, it pays to redo your problems, especially right here. I made a mistake, and I can see where I made my mistake. Now, What I'd like you also to recognize is two different types of factoring. You shouldn't be able to have to do the calculations, you just recognize it. Factoring trinomial squares and difference of squares. A perfect trinomial square is, when you separate it out, it's just become a square of something else. For example, x squared plus 6x plus 9. There's a perfect square here. X times x is x squared. There's a perfect square right there. And 9. 9 is a perfect square. 3 times 3 is 9. And see, if I know I got an x and a 3, in this case, the perfect square of the first part, perfect square of the second part, then I multiply these two together, double it. 3 times x and 3x times 2 is 6. I get this right here, 6x. So when I factor this, x squared plus 6x plus 9 is the same as x plus 3 times x plus 3. It's a perfect square trinomial, or x plus 3 squared. The second one is a difference of squares. It's very similar, except you've got two perfect squares, but you're subtracting one from the other. There's a perfect square there, x squared. There's a perfect square there, 4. Because x times x is x squared, and 2 times 2 is 4. But there's a minus sign here. And what you get for final answer is this. And x plus 2 times x minus 2. Here's some examples right here for a perfect square. X squared plus 18y plus, y squared plus 18y plus 81. Here's a perfect square here. The first one, y plus y times y is y squared. Perfect square here, 81, which is 9 times 9. And if I multiply one of these, y times 9 times 2, doubling it's 18y. And this ends up being y plus 9 squared. Difference of squares. X squared minus 49, perfect square for x. X times x. 49 is a perfect square, 7 times 7. But I got a minus sign, so it's x plus 7 times x minus 7. Now, we also have factoring sums or differences of cubes. This looks like a scary formula, but it's really just what I call a plug and chug. You plug in the letters and the numbers, you chug out an answer. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. Now the hardest part is figuring out what original a's are, because these are a cubed and b cubed. So if I have an answer here, I want to factor out a sum or difference of a cube, and this is a difference, this is a minus, x cubed minus 27. A cubed is x cubed. I'm having a squared there, my apologies. A cubed is x cubed, so a is x. X times x times x is x cubed, that's a cubed. Then my b cubed is 27, so that makes my b 9. 3 times 3. That makes, because 3 times 3 is 9 times 3 is 27. So my a is x, my b is 3. Now I'm simply going to do is take that formula for a difference of squares, this one right here, which is the same one right here. I'm going to plug my a's and b's in. X cubed minus 27, it's the original question we're looking at, equals a minus b, which is x minus 3, and then a squared is x squared, and then ab is 3 times x, and then b squared, which is 3 times 3, which is 9. Again, you're just simply plugging in and chugging it out. Now, we can look at a sum of squares and a difference of squares. Let's do a sum of squares this time. And I've written the formula out here. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. The question I'm looking at here is 27x squared plus 1. Well, if a cubed is 27x cubed, then a equals 3x, because 3x times 3x times 3x is 27x cubed. And b cubed is 1, so b is 1, because 1 times 1 times 1 is 1. Now I'm just going to plug it all in. A plus b, which is 3x plus 1. And then a squared is 3x times 3x is 9x squared. Minus ab, which is minus 3x plus b squared, which is 1 times 1 squared. Now let's do, like we did in the example before, difference of squares. A cubed minus b cubed, again, equals a minus b times a squared plus ab plus b squared. And I got 64 minus 125x cubed. Doesn't matter which order it is. We just have to be consistent when figuring out what our original a's and b's are. A cubed is 64. That means an a equals 4. 4 times 4 is 16 times 4 is 64. B cubed is 125x cubed, which means 5x is the original b. Because 5x times 5x, 25x squared times 5x again is 125x cubed. I'm just going to plug it in. So my answer would be the a minus b, which would be 4 minus 5x times a squared, which is 4 times 4 is 16, plus ab, which is 4 times 5x, which is 20x, plus b squared, which is 5x times 5x, 25x squared. Now, we can solve quadratic equations by factoring. And really what we're trying to do here is when we're looking at quadratic equations, we're trying to do an equation where it equals 0. Now, what I've done here is I've got an equation, x squared minus 8x is minus 16. I just moved the 16 on the other side so we get a full regular equation right here. And what we're going to do with this is we're going to figure out how to get to 0. And get to 0, x squared minus x plus 16 equals 0. What gives us 0? I've showed you how to factor before with the PQ method. And x squared minus x plus 16 equals x plus 4 and x minus 4. But now we've got x plus 4 times x minus, it's x minus 4 times x minus 4, or x minus 4 squared, equals 0. The only way x minus 4 squared equals 0 is if I put in a 4 for the x. 4 minus 4 is 0. 0 squared is 0. So when we solve this quadratic equation, for it to equal 0, x has to equal 4. Now here's another one. X squared plus 4x minus 21. I use the PQ method here. What equals p times q equals negative 21, and what p plus q equals 4. I've put all these possible answers in, and I get negative 3 times 7 is negative 21, negative 3 plus 7 is 4. So my answer is going to be x minus 3 times x minus 7, but it equals 0. If I put an x for 3, the whole equation equals 0. 3 minus 3 is 0, and then 3 times 7 is minus 4, but 0 times negative 4 is 0. My other answer is negative 7. Negative 7 times plus negative 3 is negative 10. Actually, it would be plus 7, wouldn't it? Yes, plus 7 minus 3 is plus 4, then plus 7 minus 7 equals 0. Now the whole thing would equal 0. Last one here. I'm not even doing a table because this is a difference of squares. 100 equals x squared. Here we write this as x squared minus 100 equals 0, which is a difference of squares. X times x is x squared, and 100 is 10 times 10. So it's 10 minus 10 times 10 plus 10, x plus 10. And x would equal 10, and x would equal negative 10 to get to a 0. Now, one of the places we use quadratic equations is for area, because we're basically squaring something, and area is usually length times width. And if I got a problem here, length of a rectangle garden is 4 meters greater than the length. The area of the garden is 96 square meters. Find length and the width. We don't know the length of the width, but we know that the length is 4 meters greater. So we'll call the width x. We'll call the length 4 plus x. And area does equal, as written up here, length times width, and they told us that answer is 96 meters in total. So whatever my length is, it's x plus 4, and then my width is x. So x times x plus 4 is going to equal 96. And I multiply this out, x times x is x squared. X times 4 is 4x. X squared plus 4x equals 96. And I'm going to solve it as a quadratic equation. I'm going to get all the numbers on one side, letters on the other. So x squared plus 4x minus 96 equals 0. I'll just rearrange it 96. And I did a table here. Use the PQ method. All the possibilities give me negative 96. And it ended up being the last one. Negative 8 times 12 is negative 96. And negative 8 plus 12 equals 4. So my factors are going to be x plus 12, x minus 8. So which one would it be? Well, it'll become 0 if x equals negative 12. However, I can't have a distance of negative 12. So we have to use the other one, 8. 8 plus 12 is 20, but then 8 minus 8 is 0. So the only answer for this is 8. So the width is 8, that's the x, and then length is 8 plus 4 is 12, and 12 times 8 is 96.